So hello everyone, we are finally back, and today we're gonna continue building our effect warehouse app. And I did some work of stream. I think I improved some of the interfaces we had before, and maybe let's start by looking at whatever I changed of stream and whatever I improved. So let's start by having a look. I separated what was before aggregated message in different things. Now we have a message ID, which is for now just an empty string. And we will use maybe later a UI ID or something like that. And then we also have changed here. We have our message that now we don't have all of the headers fields like the message ID or the fields like, let's say, other things like the correlation ID, the causation ID, etc. We have moved everything into this kind of structure called message headers. And it's a message headers. For now, we have message ID, causation ID, correlation ID. And this is also one point where we could also think about putting some trace ID in case we want distributed tracing to see a conversation across different boundaries. And I have quite a little changed the message as well. And I have, thanks to with the help of Giulio Canti, the author of FSchema, I have this kind of only on type utility. And what does this utility does is really simple. We have now the ability to attach some fields over an object, and those fields are not present into the encoded shape, but are present with a fixed default value on the runtime value. And that's exactly the case, for example, on the methods kind annotation ID and the message aggregate root name. Here we have basically the name of the entity, products, documents, users, whatever. And here we have the kind of message we have seen last time, like query, event, command, and whatever. And so here, let's have a look at our test. Maybe I can rename that. Now we are not about an aggregate message, we are about message. Okay. And now we have our test. We can see that this is our updated shape of definition. We first create an aggregate of type products, and then we define messages. We have messages of type query. In this case, this query has no parameters. We have comments, and this comment have a parameter, which is the new name. This is change product name, and this is the new name we want to give. Or events like the product name have changed. And here we have the product name with the old name and the new name. So here we have some tests that basically assure whatever we did before, that given a schema or a message, we can get the kind of message that we have. So here we expect that a query is of type query, a command is of type command, an event is of type event. And we also expect, for example, that, as I said before, when we create headers and new messages, now we expect, for example, that since this message change product name is for the aggregate of type products, we expect that the get aggregate root name of the message equals to the aggregate root name's products. And if we run this test, we can see that indeed we passed this test. Okay, so let's start moving to something new. So today I want to start having a look at how I want logic of the warehouse to persist and basically work inside of the system. And let's start by saying that I want to take kind of an event sourced approach. I want to store the event that we have just defined, and I want to recreate the current aggregate state based on that. And that would mean that basically um, we can drop any table of the system except all the event log and recreate the entire system every time, starting by reading the event log. That could be done in memory. We can have an event any table into the system, or we can have table that just holds a temporary snapshot of which is the memory representation. And before doing that, we want to scratch out. We started that the last time. We scratched out what kind of APIs we want. So we want to define first aggregate. We have two different aggregate, product and members. And now we want to create an event sourced aggregate. Here we want to pass in the aggregate root and the kind of events that aggregates support. You can now see that, for example, we can define product event journal, which is an event journal of a product aggregate that takes in events of type product name changed or product has been discontinued. And based on those two events, basically we can recreate the state of the aggregate. But indeed, you can see here that we are missing one key point. We are missing the shape of the state. So let's start maybe by defining how we want that to be tackled. I would like to do that. Maybe let's try first by doing just that in memory. So we can recreate the aggregate state in memory and then evolve from that. And maybe when we receive an event, we attempt to persist, we perform some work. And if we opt in for not having a shape, but instead performing work, that could be interesting because that means that we can, for example, use regular SQL tables and perform queries. So when product name has changed, we can perform a query that updates the name on the table, for example, and don't care about having a specific shape of the state in the event journal. And maybe I will start by adopting this kind of approach. We could try that and see what comes out from that. So I want first to have the definition of um, an event journal storage. So interface, event, journal, storage. And that interface will represent the ability of appending events. And for each event, I want an event, style event, but I would like as well to have the schema for that event. So a schema that takes the event, and I don't care too much about the encoded chip. It's fine for me to be any, but I don't want any context for now. And that is indeed an effectful operation that won't return maybe nothing for now. And there could be an error such as failure in persisting, but for now we don't care about it. We'll start real simple and evolve from that. Okay. And then when we create our event source aggregate, we want to use this interface to ensure that we persist messages into our Aquel storage. Okay, so let's start here by saying things like, okay, I would like to offend events, and that's fine. But I would also like to be able to read events. So read. And in order to be able to read events, I think that I need two things. I want to know basically the both the schema for the events that can be persisted and also the journals I want to read. Okay. So maybe we can say something like, I want to read something from an aggregate root, and we will pass in an aggregate root. And this is the aggregate. And I also want an aggregate I need to read from. And for now, I think that aggregate ID has been always be defined, but just a string, I think. But maybe that's not best. Let me have a look at message. Yeah, for now we have just defined that as an empty string. That's not so good. Maybe we can create a new domain type for that, new file, aggregate ID. And we'll do something like import everything, a schema from schema, export const per Ruby class, class, aggregate ID extends schema, empty string, and schema annotations. I want to identify that as an aggregate ID. That's perfect. Okay. And now we can update our message to import everything as aggregate ID from the aggregate ID. And here, typo aggregate ID, aggregate ID. Okay. Ideally, we shouldn't have broken anything. Ideally, because right now they are equivalent. So let's try to run our tests. Yeah, they are all passing, I think. Yep, perfect. And now let's go back where we were. We were seeing here in our Scratch file, we were saying that we want to maybe import aggregate ID. And maybe let's do something like, maybe I want to change that into export const aggregate ID equals, that's fine, export fine, aggregate ID equals schema dot schema type all type all super data. Perfect. And that's a string for now. Perfect. And this is a schema. Perfect. We need, I will say that by putting a dollar sign at the end. And in our message, we want typo to take aggregate ID schema. That's perfect. And back into the Scratch, we want to import everything as aggregate ID from aggregate ID. And now we can say aggregate ID. And I want to be able to read the journal from sequence. And this will be a number. Then basically you will say we have a journal that does this event. And I want to start reading from a specific point in time and going on. and try to create a state from that. Most of the times, this will be 0 when we start reading from the beginning. But, well, I can see situations where I would like to read maybe from a specific point in time instead of going back to the beginning. And the other thing that we are missing here is the schema of the events. So maybe something like event schema extends, and here you will have things like schema, all, and this is the event schema of type event schema. Perfect. And the return time type here, instead of having a single effect that returns a list of events, that could be one choice. I think we could opt in for using streams from effect, which are a pool-based stream, and say if I had a stream from effect schema, from effect stream, and now here we can say that this function returns a stream or schema type event schema. Okay. So this is the basic interface that will allow to persist an event into the event stream. Maybe we want also to add the information of this sequence we want to append. So maybe we can say something like schema as first argument, and then we pass in the expected sequence, and this will be a number. And basically, we have an event journal with event 0, 1, 2, 3. When we want to append, we need to know where we expect to append. And that way, if that is not the last sequence, it will fail. Or if someone is running in a race condition, where basically we have two writers trying to write with the same journal, that will fail because they will have both the same expected sequence. So one of the writer will fail and restart again, retry. So here append schema, expected sequence, and the event itself. Event. Okay, that's perfect. And maybe just a little documentation. This function allows to append new events into the journal. We expect to receive the expected sequence number in order to check for race conditions. Perfect. And read. Okay. This function returns a stream of the persisted events into the journal. Perfect. Nice. Okay, so now we have an event journal storage. And maybe we can create a file for that. So here, new file, we will have the event journal storage. Yes. Perfect. We will move this definition in here. Perfect. Export into things. Let me check. You require the input made. And we need to inform everything as aggregate boot, Roy, aggregate boot. import everything as schema from, guess what? That schema, and we need to we import a stream, yep, from effect, stream, that's perfect, and let me also check where are we missing? Oh, the aggregate ID. Import everything as aggregate ID from aggregate ID. Yeah, you screwed up. Yes, we are still having a one. Oh, FS, yes, to make that effect as well. Import everything as effect from effect. Okay. Yeah, it's ship. Perfect. Now we don't have any errors as well. Okay, so let's try to write maybe mostly as a something that we will use in tests. Let's try to build an in-memory implementation of the event journal, and maybe we can do something like first we can define a tag. So import everything is from text from head from text. Okay, export plus. Oh yeah, I know there is this new fancy API I want to try from Effect that allows you to create both the type definition and the actual tag in the same thing. So I should be able to do something like, let me rename just this one for a second. I should be able to do something like extends context dot tag, and I think I need to provide in the ID for that. Yeah. So event journal storage maybe. And this is the event journal. Oh no, I need to provide that later. This one. And then I need to provide the event journal. I hate when you do that for me. Yep. Perfect. And then I think we are golden. Yep, you need two type arguments, which is the second one. Oh, the shape, yeah, indeed. And that's what we have here. So if I copy this one and put it here and format it, yep. This is a new fancy API from Effect that allows you to define in the same place both the tag for a service. So event journal storage. Let's just use that thing on the same thing. And I think one of the benefits of that is that we should get for free things like on event journal storage plus a equals event journal storage download. There should be ideally things that allows you to get. Oh, here they are. Yeah, that effect of things. Yeah. Yeah. That's really nice. Yeah. Yeah. Okay, so enough messing around. And now we need to create, as I said before, an in-memory implementation. So let's start with saying export host in memory equals fact one gen function store. Okay. So I need to create a ref or something in memory. So import everything as ref from fact ref, and the ref will hold basically the state. So, and we'll say cause state equals here is star graph.make, and we will start by having, we need to index both the aggregate root, the aggregate ID, and then we will have an array. So we can say something like, maybe we can ladder it out, but I would like to index that. So maybe we can use something like imports everything as passionate from effect passionate. We will use an passionate passionate, and the passionate will have as key the aggregate root, and as a value another passionate that has as key the aggregate ID, and as value we will have basically an array any. Yeah, that's fine. Yeah. So now you're complaining. You are complaining why? Because here we want any value. Yeah. And oh yeah, empty. Like make, yeah. And make takes, if I remember correctly, for an astronaut, type definition. Yeah, takes value, then next step. Okay. So make, then, oh, that's the error. Yeah. We need to provide the actual value that will be an empty hash map by default. Yeah. So this is our state. We have here RS that will hold our aggregate root, and then we have our aggregate ID, and finally we have the list of events. And that's perfect. But first, we need to ensure that we have proper hashing. Either maybe we can use an aggregate name or have proper hashing of aggregates in order to be able to ensure that we look up correctly. So maybe let's start simple by having just a string here, and which is the aggregate name, the ID, and etc. So let's start by writing the append function. So const append will be something that we will take in. We will take in basically the schema. We don't care because we are using in memory the expected sequence and the event. Oh yeah, you can see here that I forgot something really important. We still need to provide the aggregate and the aggregate root because we need to tell to which aggregate we want to append things. Here, yeah. That's better, indeed. So that's format everything. Yeah. Aggregate root, aggregate ID, and maybe we can put it later the expected sequence, the schema, and event. Yeah, I feel very comfortable with this. Sequence, okay, so they are basically similar. And then we have const append, which is, now we have, this is basically clear and journal storage type append. And this will be root aggregate ID, and then we have expected sequence, and then we have a schema. You don't care about that, and we have finally the event. Okay, so this will be an effect, and we need to update our rep, and we need to say first. We can do that all in one shot, I think. Yeah, because ref is in memory. So we can do maybe just ref dot date, And we have our state ref. Okay, and now we need to provide a function that, given the old value, the old state, creates the new one. So that needs to happen in some steps, I think. I think that we need to first get into our, from our old state, we need to get the aggregate root name. Okay. This we need to import this. Okay. And this will return an option, and we're not fine by that. And that's because basically we can say option, we need to import option maybe. Import everything as option from fact option. Okay. And option get or else. So if we didn't find anything under this aggregate root name, we start with Perl hashma dot empty. So we will basically get an empty one if it doesn't exist yet for that specific aggregate here. And then we also need, now that we have the hashma entry, this is the entry. And now this entry, we need to say something like hashmat dot get, and we will get basically the aggregate ID. And this is basically the inner hash map, this one, the one that has this. And for this, maybe we can say something like calling this inner marks equals, or maybe current array. Yep. And this is the current array here, as you can see. That may not exist yet. And as again, if it doesn't exist yet, we can say something like option gather else and use an empty array. It doesn't exist. Yeah. So this is basically the current event array. And we will say that we want to basically concat the events and set those into the key of the aggregator. So we should have a method, modify it, I think. Sets of remove the specific carries in the ventilation. Will be eventually. They will be invoked with the current value of the key hit exists or no key, no such value exists. Yeah. Perfect. So modify hat, old state on the key aggregate root, aggregate root name, and this is our update function. And this is our update function. We'll have maybe state, and this should be an option. Yep, an option on the national. And we will say something like fine. Maybe state option again or else version empty here. Perfect. And now we have the instrument. And here we'll say again version and modify it C is aggregate ID, and maybe event list equals here, maybe event list option get else and array, and then we'll have also import everything as arrays from effect array dot append. We'll have our event. Here, that's fine. What are you complaining now about? Oh, modify at wants to, let's say, let's go to the definition. It uses an update function, and the update function takes in an option and removes an option. Perfect. So we need to say, basically, just here we get else, we modify, and then here we say option sum, and the same goes here. Option sum. What did I screw up? Yeah, you're right. Yeah, yeah. You're right. You're right. You're right. Right. You're right. We want to say that this is this one, made a state. And if we have that, if we don't have that, Ashpot never or A. Why are you saying that A is the thing? It's not A. It's something completely different. Yeah. Let's see. Let's see. I'm not modify here. If we have that. In the hand that we have an empty. Yeah, and that's fine. But you're not happy with that? And why are you not happy with that? I don't fully understand. So let's start in the email thing. Here. Oh, because this is, oh yeah, I see. Ashpot and empty that takes an aggregate ID from the ID, then takes any. Yep, now you have to. Yep, TypeScript. That's it. And that should be what we were looking for. Here. And now we need to do the same thing, but to read all of the events. So we can say const read and will be of when dual storage. Read create equals. We have aggregate root. We'll have aggregate ID. Whereas from sequence, and we have the schema we don't care about because we are writing an in-memory representation, so we don't need, again, to serialize or deserialize. So, let's see. Now, we should do something exactly like before. Saying like, flip our state ref dot get from our state. We read our entire state. When we have our entire state, we say something like affect dot map. We have state value, and from the state value, you say state value freshman dot get, and the key we want to get is already truth. type name. And if we don't have that, again, get else, question empty, with a string key and alias value. And then we want again to say that here we get the first level, which is from the aggregated name, and then we say again get. We want to begin the aggregate ID, and if we don't have that, we are fine returning as an empty array, and this will think the TypeScript is yelling at us because now we have an array of events that is not assignable to an array of schema, and they are not also compatible because this is an effect and is not a stream. So first we need also to do something like a stream from iterable, and that will return a stream, but now it's a stream of any and not of that. So we need to screen wrap, I think it's called. Yeah, stream.unwrap. The stream.unwrap, what does is if we have an effect that returns a stream, it unwraps the effect into the stream so that it's performed while acquisition and releasing, and then we have our perfect stream. Perfect. And now we have defined both append and read, and we'll say return, append, and read. And this is ideally our in-memory service. Okay, but now we need to convert this effect into a layer to use it. So let's say that import everything as layer from effect layer, and we'll see that we can convert this effect layer from effect, and we need to provide the tag, which is our event journal storage. And look at the magic. Now we have a layer that constructs an event journal storage. Perfect. Okay, so here now we have our effect. We have something that is complaining about. Let me see. Oh yeah, from sequence, we actually didn't use that. So that's a use value. Perfect. Okay. Let's maybe write some tests to ensure that this actually works. A new file. Album journal storage dot test dot yes. Okay, so let's start by copying from this. Okay, we will use just this. I don't care about everything else. Perfect. So we want to describe the capabilities of our event journal storage. And this is actually really simple because what we want to do is just say we want first here it's not the effect. We want to say that journal should persist then re messages events, sorry. Okay, and we need to provide a function. Okay, and First, we need to define class sample event one extends a schema target class. Yeah, that's fine. Sample event one. Yep. We want the identifier. No. Okay, so the tag is sample event one, and the fields we will have nothing for now. And we will do the same thing as sample event share, sample event shares, sample event sharing, and const event union equals schema union of sample event one, sample event two. Okay. So here they will say something like we want effect gen clinician store. So const journal equals fields, and here we want to import everything as event journal storage on from src event journal storage, the event journal storage event journal, and now we will have an instance of nothing. Why? Why? And, yellow star. Oh yeah. And now we have our journal. Perfect. And now what we test is that if we do something like, first we need to provide dot type effect dot provide and event journal storage in memory. Okay, and now you can see that it's empty because before it had a requirement of the event journal, and now we provide the in-memory representation. Now we try to say something like we journal the event, an event. We need to provide an actual aggregate root. Yeah, so we need to import everything as. Do we really want the entire aggregate root? Yeah, maybe we are fine with just the aggregate name, I think. Yeah, let's change that. Let evolve the thing. Yeah. Maybe we can just say clear. We'll just aggregate root name. And the symbols for the. Oh yeah, that's the old one. Yeah, sorry. Forgot to delete that. Yeah. And I was saying that I don't care about actually using an object. I'm fine by just having the aggregate root name instead of the entire aggregate root definition for now. And strings aggregate root name. That's the that we need to apply here. This is aggregate root name. And this is the as well the aggregate root name. Rename aggregate root name. And here as well. Aggregate root name. Perfect. Save. Okay. And now we don't need this dependency anymore. We have uncoupled our service basically. And that's always a good thing. Okay. Event union. So I said append. Let's have a look. I will need to provide. aggregate root products, product 1, and expect this sequence for 9, we can say 1, event union. I will say new sample event 2. Okay. And now we want to read events all the journal. So journal dot read for the same products, product 1 from sequence 0, the event union, and this will be a stream. But I think that if we yield the stream, yeah, we cannot yield that, but we can yield stream dot, yeah, and to import stream, import everything as stream from effect stream dot read collect and collects here. And these events now is a chunk, perfect, of those. And oh yeah, perfect. Import everything as chunk from effect chunk. And now we can say that we expect chunk.length size of events to equal 1. Basically, we have added a new event and we expect that to be true. And that's indeed the case. And I want to add another test, which is very similar. But what does is we add an event to basically journal should differentiate entities. If we add it to product 1, but then we read from product 2, I want that to be 0. And let's check. If we run this test, this pass, perfect. So all of our tests should be passing right now. Perfect. So we have now a simple in-memory event journal. That's something that will allow us to mock our implementations. So let's go on. Now that we have an event journal storage, we append things and we read things from that. Now I want to get into the stuff of actually defining the actual event sourced entities. So let's call it, let's go back to our scratch. I want to call event journal, we have defined, we don't care anymore. So I want to call it something like, I need an aggregate root to create that, and that's perfect because I will pick the name from that. I want events from that, and that's fine. But I also want here, the ability to update without using effects. So as we said before, with that method, we persist event. And I was thinking that maybe we should add a type parameter. Maybe we should add a type parameter of the environment that is required by the event journal. For now, maybe we can start without that, but I could see that that could be useful. But yeah, let's go back to what we were trying to do. And then we will say that a syntax like that is really what I'm looking for. You have the aggregate, and then we have the schemas of the all possible events. And that's perfect. The only thing is that maybe in given journal, instead of having things like a single union, if you remember, we passed a single union of the event schema. Maybe it could be interesting, instead of having a union, of passing an array with the single elements. And that's because if I know, I can statically know, if I take a look at product name change dot, we should have tag in here, and this is the actual tag. So if we persist, if we have, let's say, one storage that persists that as well, we could implement logic that actually fetches only the kind of the events that are supported by the aggregate, instead of fetching them all. This could be really interesting, indeed. Yeah, that could be really interesting. But that won't change much into the APIs. That will change just the event journal storage API. I think that this API will stay the same. Yeah. Okay, so let's go back. Okay. So let's rename this make. This A is basically the aggregate. Stance aggregate root dot all. This is the aggregate. Perfect. And then we want to take in the list of events. That's perfect. Then we have the update aggregate state. I think that maybe this already fully describes what I want. Yeah. I was thinking that there is something else I want. Maybe I want to provide an initial state as well. Yeah, I want to provide maybe a product aggregate, an initial state, both aggregate, a product aggregate, and a state schema. And then I will provide an initial state. Yeah. Let's reason for a second about what we want. So we want to have the aggregate that's needed to get the correct stream. And then we also want the event types used both to read and persist the storage. And I'm debating if I want to have a state shape or not. Yeah, for now, let's try just with the state shape and do everything in a cool way. Yeah, for maybe as a starter, we can do that. And so I was saying, yeah, I want the aggregate, I want the events type, and I want the state shape. And that means that I want also the initial state. Okay. So we want the, maybe we can say something like interface. and the arguments. Yeah, we want the aggregate fruit, making the of types aggregate. And then I also want, as I said, the event types. Events. And let's put this one. The thing is that I don't know if TypeScript will be smart enough to understand that those key type signatures are one related to the other. I don't really think so. Usually it's not so smart, but we can try. Let's see if we say that those are the type parameters. Yep. And then I want the args to be on height be then shoes aggregate args aggregate and then events. Perfect. Save. Let's just loop in here. Now we will need to update that and say aggregate root is product aggregate and events are those ones. Okay. Yeah, doesn't seem to be so smart about it. Schema type and wise. Oh yeah, that's true. That's true. Let's maybe just remove that for now and have a look on the inferring that's occurring there. Are you inferring everything correctly? Yeah, it seems so. Product name change or product discontinued. That's perfect. And now that we have that, let's now that we have that, we could see that maybe we can also pass in here the state shape. So we want the state, extend the schema because we need to persist everything. Schema.whole and stay and here state extends schema state added all and the state of type state. Perfect. Now it's okay. It's complaining. And let's say that the state is of kind, for now let's just use k dot string. Yeah, perfect. Type of string. Seems that it's working. Now what I really want to try, if type is smart enough to say that if I say member joined, are you complaining? Yeah. Yeah, it's smart enough. Yep, it's smart enough. Yeah. And that's really good. Maybe I can rename these to event types. And this is the state. Yeah, perfectly. Perfectly. And now the last thing that I need to pass in, and maybe I can do that in here in the same function, is the readers that given the state and the event, schema type of events, wonder, Oh yeah, state is a schema as well. So schema type of the state will return an updated state. So schema type of the state. Okay, so right now it should be complaining, yeah, because here, okay, now it's complaining because we are missing a time parameter, which is readers, and we will see that we have our state, which is a string, and product name changed, our product discontinued. Perfect. So let's say that, for example, our state was a schema.option of a string, and we could, for example, in our Dream World API, to do something like event, and then say reach event thought, and based on the case of the product name changed, we want to the state to the option.sum sum of the event dot new name. We need obviously to import option from set option. And in case we have a product discontinued, we can just say return option dot none to say that the product is now discontinued. I really, really like this. And yeah, and obviously if someone needs, for example, to say state dot, I can also access the old state, and into the event, we also have ethers with additional information like the message ID and whatever. Yeah. I really, really like this. Yeah. I think that we are going into the right direction. Again, here, that's really nice because now if I say, for example, member join, it will complain that that's not one of the events of the products aggregate. Yeah. Okay. So now that we have done that, we need basically to define the APIs of our event sourced aggregate. And I think that the APIs are quite simple because if I think about that, the kind of operation I want to do are basically accessing the current state on the aggregate. And if I would just want to read the state, that's it. If I want to update the state, I need to append new events into the aggregate. So we can do something like, um, I don't care about that anymore. Interface and source aggregate, not args, but just the actual aggregate. We will have the same type parameters of the schema. Yep. And here we will have maybe an API that's just uh, modify, maybe. And this modify will have function that have the current state. I'm not sure if I want to pass in. Maybe instead of passing in the current state, I could do something like I get back both the function to read the current state and one to append. Yeah. I will basically get back a read. There will be an effect dot effect dot effect, and it obviously imports effect. In fact, I want to have an effect that reads the schema dot type of our event source aggregate. So we have the state here. Yep. And then I want also to legend append, and that append will take in an event pop type schema dot schema. Do I really care in the actual event source aggregate about the schema? I mean, I care about it when I make it, but once I actually have the instance, maybe I don't care about the schema anymore. Because the schema is just an internal thing to persist it. Yeah. I think that the aggregate is okay. And the events can be just, and if for aggregate, for now, let's just use the schema. Later on, I think that I don't actually care about that. An event is one of type schema dot type of events number. I can append one of these events and delete it fact dot effect void. Okay. This all modify will be an effect dot void. Okay, so I can modify, and the modify will have rev and append. Yeah, maybe I should extract those into something better. Yeah, into something like interface and source aggregate draft. I will call that. Yeah, draft. Aggregate extends. I don't care about the aggregate, because I already have that. I only care about read. I don't care about the aggregate. I just care about the events. Events, and the other one is the state. And this will be a function, as I said, that will return an effect does fent void, so an effect that does nothing, but will get as arguments to function that are read, and this will be an effect of state and append that will basically take any event. So events and return effect dot effect void. I was thinking about that, and modify will take in a draft function. So draft, which is here, and then series aggregate draft, and here we pass the schema dot schema type of events number, and the schema dot schema type of the state. Okay. So now hypothetically on product event journal, if I say product event journal dot, I need to return it that. In make, where is my make? Here, this should return an event source aggregate, aggregate, the events, and state. For now, it's just a mockup of the APIs, so I don't care, but modify. And here we have a function that takes symbol read, pens, and here I can do whatever I want. If I call read, read will get an option of the string, which is the state, and append can append an event of type product name changed or product discontinued. Perfect. Perfect, perfect, perfect. And now we need to provide the actual implementation. And that is a little trickier. Okay, so the actual implementation for that. Let's go back to our make. Okay, so we have all the arguments. Now we need to return a modify function. Maybe we don't actually need to have a method. You can just use that as a function, but for now, yeah. So now let's use the method. So constant modify equals. We want to create our event source aggregate graph. So modify needs to do something. So first we need to acquire the journal. I also need to import that. Event source, scroll storage, event terminal storage. Now that we have it, we will event source journal. Okay. Buttons. We have our journal. And this is the journal. Yep. Little journal. Correct. Here it is. Okay. Here we have our journal. And now when we modify, the first thing that we need to do is in journal dot read, and we want to say const dot read truth. And we are, oh, and I see what I'm missing. Yeah. Yeah. When I call modify, here I need to tell which which entity, which aggregate ID I want to modify. So it would be something like and then we get that read send yeah. So modify will get our aggregate ID in aggregate ID aggregate ID. Let's fix the import. Okay. Okay, and I want to read the journal for that aggregate root with that aggregate ID from SQL 0. And the event schema, guess what? We already have that. It just says schema.union args.event types. And ideally, that will return a stream of all the events. So perfect. And this is just an effect with a stream of our events. Obviously, that is not well typed, yeah, because of this. And what are you caring about? Schema union, event types. Event types is, if I remember that one, events, which is a read-only array. Yeah, scale variant. This should work. But now what do I want? Any family read? And is not so anyone is with you? Why are you feeling me? Let me check later down that. Yeah. We wanted indeed to change this layout. So maybe we can do that, but yeah. Yeah, let me check. We can change that and say that instead of having a single schema for the event, what we could do is instead have an array of schemas. Yeah, let's change to that. Events stands an array of schema all, and that is events. And now event is schema type of the events number. Okay, so we change a little the semantic. The same goes for it. Can say maybe events extends array on this. And then we have schema only of events number. Perfect. And now here same events number. Perfect. Oh, sorry. That's wrong. We want events. And that's it. So given the schema, we get back all the events. Yeah. Perfect. And let's go back to our Scratch. Okay. And now we already have that. That's it. That's it. Yeah. Events is all read only. And if I give it is read only, I cannot be assigned to type all. Oh, yeah. Is read only. Is read only because that is a read only array. And maybe we can change that into the storage as well. A read only array and read only array. Or maybe iterable. Yeah, maybe read only array. So that's better, yeah. Okay. Okay. So here, events, and read only, any for aggregate. Oh, any for aggregate is just a subtype. Oh, yeah. But yeah, that's fine. We can just cast those. Yeah, that's fine. Yeah, that's fine. Okay. Now we have basically read the entire journal, so we can stream dot unwrapped, and now we get a stream is the only effect of stream. Perfect. And then we say something like stream dot run fold, I think it's called. Yeah. And that starts from an initial state. Parks dot. Oh, that's the other argument we are missing. State. Initial state. And the initial state, I think, the based on here aggregate ID. Aggregate ID. And we'll map basically this schema. It's dot schema dot type of the state. That's it. So here unfold args dot initial state for that aggregate ID. Okay, and our fold is, guess what? Args dot reduce. Yeah. Oh yeah, we have unknown. will state events state. Oh, the event is now unknown due to that. Yeah. Uh, Here we can just say that events type as any plus events. Why don't you want events? It's nothing simple type with only all. Let me check. I expected that to work, but I think that the problem is that if I am asking too much from inference, my inference here is having a really hard time. Event schema, yeah, it's having a too much hard time inferring from this. Yeah, unfortunately. Oh, that's a shame. So maybe move 20 instead of at all. Any, no context, to be honest. That's the real thing. I don't want to care about context for now. At least in the encoding decoding part. Okay. No, the problem is the same, right? Yeah. Any fragment is missing. Any fragment is not a schema. Why are you expecting any? Where it is, where it is, where it is, where it is, where it is. Message. Any fragment. Are you happy now? Maybe. I don't know. Let's see. No, I think not. I built everything. Oh no. Well, that's expected. I need to pass an union now instead of the specific event. Yeah, that's fine. That's expected. Where are the errors right now? Here says welcome here. We don't need to pass the event in anymore. Sampling 1, sampling 2. Okay, that's better. That is how it is expected to work. Yeah. Okay, and now that we have fixed how it's expected to work, let's go back to our Scratch. Oh, guess what? Now types work. And now events should be correctly typed. Yeah, that's nice. And now state reduce should work. Oh, yes. Have a look at it. Okay. So, this is actually a read current state from journal. Okay. And this is an internal utility that we'll have to have. And now we need to create a function that basically creates the draft. And the draft will work as this. We will first read all events from storage and create the current state. And that's what the first function we have implemented right now does. And secondly, we want to create a ref storing the current state. And third, we want to do things such as create an append function that will both update the ref and persist the event to journal. So it will do both. And then I think that's it. Package those two into the object. That's our plan. Okay. Okay, so we have a way to read all events from read core state from journal that will create that, and we'll obviously use the event journal storage service. And now we need to create the draft functions. And I was thinking that, yeah, I could create those because we already set an effect. Yeah, we already set an effect. So I can create those. So that will work something like that. Cast modify equals effect.gen function star I said. Okay. Uh, calls current state equals yields star read current state from journal. Oh, obviously we need to say aggregate ID, aggregate ID, aggregate ID. So read the current state from journal for the aggregate ID, and then const current state ref, maybe state ref equals. We need to create an effect ref again. Ref dot. We need to import that. Import everything as ref on effect ref, and let's go back where we were. Okay, ref dot me. The initial state will be the current state. Maybe let's call it just initial state. That's better. Initial state. Okay. And then we have our state ref that holds that in. Perfect. And the read function will be nothing more than ref.get state ref. And that is the same shape of read. That's perfect. And then we have cons append that will take an event. An event can be of type events. Here we can be of type schema dot type of events number. Okay, we have the event. And when we get an event, we need to do some things. So we need to read the journal. We need to read the journal. So basically, then source journal storage. And now that we have the journal, and select dot journal, we will do journal dot end aggregate root sorry, args. It's in args dot aggregate root name. We have the aggregate ID. And here we also need to keep track of the expected sequence. Right. Yeah. Args dot event types in the broad event. That's what we need to do. And after we have done that, we need to update our so effect dot top we will ref dot modify. Sorry, not modify, but update. We have our state flag, and the function will do basically something like current state, and then args though it is current state event. Okay, and that will update the ref. We also need, as I said, also not just the state, but we also need to provide the expected sequence. So when we read the journal, I think that we need to provide both the journal event and the sequence, I think. Yeah. So let's say something like explore the interface, event journal storage entry of type events, and that has a sequence, which is a number, and event, which is of type event. Okay. 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 And now, instead of returning a stream of just events, we return a stream of event journal storage entry. An event journal storage entry of only this. Yeah. Okay. And we need to change this as well, because here we have a stream from iterable, but yeah. Here instead we need to redot, and we have both the event and the sequence tips, and so we need to pack those as an object. The event and sequence. Perfect. Now this work as well, but the thing is that now in our Scratch, when we read the current state and we run fold, we start from the initial state, but we want to have both the state and the last sequence. So we can do something like state is this, and last sequence is 0. That is what we start from. And then we say that you and the state and last sequence the sequence. We update saying that now the state sequence, yeah, and then we also have the event sequence, and this is not useful. Yep. And with the args, you can say that the new state is your state is just args.readers, current state, and the event. I don't know if I care about providing the whole event journal entry. Maybe I care. Let's try to make it this more plain. Yeah. Maybe we can do something like for class. It tells. Um, maybe I care about that. Yeah. Maybe I care indeed. Because here I have the whole journal entry. Yeah. That has both the sequence and the event. Yeah. And here in our reduce, we will get both the event and the will, and I need to export that interface maybe. And journal storage entry, yeah, should be as well. And journal storage dot of type event. It's perfect. Choose state. He will take both the entry. This journal entry. So it's the journal entry needs, and the last sequence will be the journal entry dot symbols. Because we expect to read the journal in order. Okay. So now this is changed a little. Now we get an effect that returns a state and past sequence. Perfect. And maybe we can change that to current state. Perfect. Okay. So we have current state, last sequence, current state. Okay. And we also need to const sequence math equals use star math dot make last sequence. Perfect. Perfect. And then, okay. And then we need to change this a little. Maybe I can just switch to prefect.gen, which is more readable. Function, stars, here's journal, here's just time. This one. And then we need to choose to events equals this. Okay. And yeah, we need to append event. Yeah, so it's heals star is to happen. We also need to optimistically approves our new sequence will be wills first without date and get sequence fill and with test one. So we are out the new sequence. Okay. And now that we have a new sequence and we append it, we also need to modify our in-memory representation. And we can easily do that by saying update, and you say that current state. Oh yeah, we need to provide this state ref, current state, and that's our state. Yeah, and we call args.students with current state and the event. Now we can optimistically create that and say that the event is the event we passed, and the sequence is our new sequence, and we'll rename to just sequence. But it makes sense. Okay. Event sequence. I think that now we don't have anything that's complaining. Yeah. So now we have created read, append, and now we just need to. I think that now we just need to pack those as function and call it. And that's it. Yeah. Yeah. So modify, we said that also needs to take in aggregate ID, aggregate ID, aggregate ID, and the draft function. And that's the I haven't searched aggregate, and now that's fine. It's not complaining anymore. Perfect. And then what we also need to do is say now that this modify here we have to find that. Let's find that. Okay. Okay. And now we should have both the aggregate ID and the draft, which is aggregate 11 source node. And source aggregate draft schema.type events number, and that means schema type state, I think, if I'm in the front. Yeah. If one is to type arguments, did I miss? Oh yeah, I missed one here. Okay, and that's perfect. Okay, and now draft is callable with wait and append perfectly. Oh yeah, the thing is that instead of reading the journal in here, we need to read the journal on the side. Perfect. So now that works. And now that we have that returns an effect. So we just need to yield that. And we should be golden. We should now have our event source implementation that works. Let's try. Our initial state, this should be option of none example. Why are you complaining? Yeah, option known or string. Are you happy now? Oh yeah. Oops, silly me. The problem is not that. The problem is that is lazy. Yeah. Okay. Yeah. Now that's not the thing anymore. If I want just the event, I need to destructure that. Yeah. Now the thing is that here I can do things like pipe, read, and that can be at me or just append, and I can append whatever event I want. Perfect. I'm not happy with the modify name. I don't know if you guys can came up with a better name. It's something like touch or modify with draft, something like that. Because actually I get a draft. And oh, what are all these squiggly lines? Oh yeah, now I can format. Here I actually need to eventually return modify, and it will complain because oh yeah, that's true. Because in defining modify, I lied. Yeah, that's actually a good name. Yeah, I could just use produce. I used immer in the past. Yeah, after you modify the callback you pass. Yeah, that's the same thing basically I'm trying to do. This is the draft. The couple of method read and append is basically my draft. I can read the draft or append events into the draft, and as I append events into the draft, the read function will read the updated version. Yeah. Yeah. And thanks for the suggestion. And anyway, welcome to the stream. Let's see. We call that produce. So let's check that back. Pum, 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 pum. Here we have the draft, and the draft is a method in here. And so maybe I can call it that this draft callback, and I want another interface just for the specific draft, and the draft will have the properties read and append. Okay, that seems more reasonable. And here I can have draft, which is event sourced, aggregate draft, events, state. Yep, that's better. Okay, let's have a draft callback. And the draft callback isn't so useful. Maybe I can just define the produce instead. Even source aggregate producer. Okay. And the producer is a function that takes in both the aggregate ID curly and the function that given the function that given the draft returns an effect point. Okay. Here and now this is instead of that is event source aggregate producer of events schema.type events number and schema.type state. Okay. And aggregate ID is obviously of type aggregate ID dot aggregate ID. Okay. So now this is a produce, and now instead of having two parameters, I have an object which I can deconstruct. Here, read is read, append is append. Perfect. Yeah, for example, I append it, and that's it. And here I can say, for example, new, and say product name changed because for some reason it's changed, and I can create a new product name. Yes, perfect. We are slowly working through the APIs that I want. Maybe we can start by before ending the stream. Yeah, we have, I think, other 15 minutes, something like that. I think that before ending the stream, I want to clean up this and do some things like produce here. And this produce is event sourced aggregate producer. If I take, say, this schema type of events. Yeah, it's another events, a number, and the state schema type of the state, so that Here, I don't need to type in the specific types. Okay. Because ideally, now they are correctly typed. Perfect. And now it's complaining because that's the thing I said before. I got my types wrong. And the producer actually needs an access to the event journal. So the producer will return an effect that returns maybe void, but no errors for now, but requires event journal storage, event journal storage. And now we should almost be ready. Yeah, right. Now we have an object instead of just one. Yeah, draft is an object. Here we are going to click the white spaces. Yeah. Slowly but surely, I think that we are ready to start to move things into a separate file. So we clean up everything. But yeah, this is roughly what you should do. Let's go back to what we do. We have a produce in here. The produce will take in an aggregate ID, and then you get basically the function either for appending or for reading the current state of the aggregate. And when you append an event, what happens is that the event is both appended into the storage and also it's appended into the actual in-memory representation, and the in-memory representation is updated. And each time we call produce, what we do is we read the whole history of the events from the journal, and we recreate the memory representation on the domain aggregate, and we read that, use that as a draft, we append events, and that's it. Yeah. So let's try maybe to move things just to clean up some things. So let's start by creating a new file. Events first aggregate.yes. Okay, let's start by saying that we want first div things. We want to import everything as aggregate food from the aggregate root. We need also the aggregate message. Sorry, it's not called aggregate message anymore. It's called just a message. In message. So we need to update any. Yeah, here the name symbol. It's not called that, so we need to update that as message. Sith. This is an unused import. So that is just message. We need to import fx schema. Okay, and we need to import the aggregate ID. Yeah, aggregate ID. Yeah. Yeah, I'm getting hungry. I will soon end the stream to go get something to eat. It's almost dinner time. I'm not sure about you guys, but definitely getting so much angry. Yes. Events, journals, storage, from event journal storage. And I think that's all of those for the interface. So we moved to the interface, and we also need the producer. Here. And we need to import effect. Effect. No. And now let me add effect imported. What are we missing? Nothing else. So it's, I think, yes. We need the interface for the event sourced aggregate, which is basically the main thing of this module. We need to export as well. And that relies on the user. I will put after that. Okay. And that relies on no draft. Here it is. The draft. Here we've put the draft in between. Yeah. Okay. And finally, we have our make function here. And we'll say export function link. And we need to import. We have some types that we just imported that we need to change as real imports. And stream and effect as well. Stream and effect as well. Well, stream we didn't import. Import everything as stream from effect stream. Okay, and what are we missing in here? I think a lot of things. Missing what? Oh, ref. Cannot find name. Right. Yeah. Import everything as ref from effect. Right. Okay. Oh, sure. Whatever question you want, we're here. Um, wait, why did I do that in this module? I don't know. Message. Oh, maybe it was the beep message from. Oh, I should instantly rename that to message. Oh, man. Why did I do that? That was schema. Okay. Now we fix that. And then now she's this message. Oh, yeah, because before I renamed something that broke everything. Yeah. And yeah, I think that I will just think moving few things in here, fixing two things in here, message. 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 Okay, we should not have any problem here. I think that I will just import everything as the model we just created is so with that, I think that I'll close here the stream. I'm really happy of what we did today. We basically have written all the code for the event journal storage. and the actual event source aggregate implementation. And next stream, I think that we will write some tests for those and see if they actually behave how we expect. And maybe we will start implementing a real world journal that we will use based maybe on SQLite or SQL. And for that, I think that we will use indeed SQL. And with that, I thank you all for joining the stream. And we will see you next Thursday. So 1 week from now. Next Tuesday. So we will see in 1 week from now at 6:30 Rome time. And thank you again for joining the stream. And please follow me on Twitter if you want to get notified from next stream. And thank you again. Have a nice day. Bye bye. See you everyone.